Assalamualaikum and hi, we are from Group H and here we will explain the question number 3. First, we will tell about this filter. The filter used in this question is high pass filter. A high pass filter is the exact opposite to the low pass filter circuit as the two components have been interchanged with the filter output signal now be taken from the across resistor, whereas the low pass filter only allows signals to pass below its cut-off frequency point Fc. The passive high-pass filter circuit, as its name implies, is as it named. It only passes signal above the selected cut-off frequency Fc, eliminating any low-frequency signals from the waveform. Okay, from this question, we will find the impulse response Hp from the frequency response function. So this is using MATLAB. We're going to run this function and I will explain you about this coding first. And this is the function, the frequency response. This is the function and this is the heavy side. This is the impulse response that we want to get by inverse the Fourier transform of the frequency response. Then we got the impulse response. So this is how we're gonna show it up in the command prompt. This is the answer of impulse response that we got, and this is how we're gonna display on the command prompt, and this is the graph of the impulse response. As we can see, this graph is about negative sign. You can see here and here, from negative 5 to 5. Okay, next we will move to output response of xt given by sine 5t over pi and xt when we plot xt and yt. First, I will find the xt first. Okay, we will compute the sine function. Sin. Okay, this sine is sine t over t. Okay, this is how we got sine, but I just used the formula. I used the normal sine function where it used 5t over t, whereas in the graph that shown, the zeros is not on the integer. It's a point number. So we got the xt, the input response xt. Next, I will show up about the yt. How we got the yt is from the convolution. Convolution is wait a minute. Convolution is a yt where we multiplying the impulse response with the input response. So the impulse response we got from the question A and the input response is sine. And when we got the impulse response, when we use a DRC differential, Input waveform to the filter has been assumed to be sinusoidal or that sine wave consisting of fundamental signal and some harmonics operating in the frequency domain, giving us a frequency domain response of the filter. So this is how about the filter is using the normal sine wave, and we want to find the convolution of the functions. And this is the yt value will show up in the command window, and this is the graph for the output response yt. As you can see, it's a linear graph and it's a negative t. Next, I will do the question C, that is when the input is periodic signal rectangular. However, if we fit the high-pass filter with a square wave signal operating in the time domain, giving an impulse or step response, the output waveform will consist of short-duration pass or spikes. Means it will, from here, we can see is a rectangular, but if the input, this is an input, and when we modulate it with a signal sign, it will spike a little bit, like here, and here, and here, and here, just spike a little bit. So I will show up the signal that I got to show that it's like this. So I run it with a bit, and this is what I got from -2, you can see, up way until infinity, and we want to find the convolution. So the convolution is same as usual. We do x time with h. This is the convolution. We showed out the convolution function. Okay, this is the convolution function, and I will run it, where x1 is the rectangle path, and y and h is the impulse path of the equation A, and this is what we got, a linear where is the value is at 0.2602 at the amplitude. This is got 0 at the x-axis, and this is the output response that we got. Thank you.